Hi, this is Don Clark with NEC. Today, Arvind Sukumar and I are going to demonstrate a multi-vendor software-defined Ethernet fabric powered by NEC and Pica8. We'll show software-defined multi-tenant network virtualization based on NEC's award-winning programmable flow controller. We'll show a multi-vendor network demonstrating switches from Edgecore, Inventec, and Dell. The demo will include point-to-point and point-to-multipoint Ethernet services, centralized network management with zero-touch provisioning, and high availability at the link, device, and network level with a cluster controller. The benefits of this solution include no hardware vendor lock-in, high throughput, non-blocking network fabric, easy to manage centralized control with network visualization, secure traffic isolation, wide variety of supported platforms, and a highly available, highly scalable solution. Now I'll turn it over to Arvind Sukumar for the demo. Arvind?
This is Arvind Sukumar from NEC, and I'm going to show how NEC and Pica8 open networking solution would be useful for the data center providers. This network has 4 switches, 2 100 gig switches and 2 of 10 gig switches. As you can see, we have no vendor lock-in. We have Dell, Inventec, Edgecore, and also NEC switches which run OpenFlow, and there are going to be 4 tenants being a part of this data center, and all these switches are centrally managed by the NEC's PF5840 SDN controller. And this SDN controller is again managed by another layer called the Unified Network Coordinator, which can manage up to 40 SDN controllers. In this diagram, we are going to take 2 use cases. So the first case uses the tenants A and B. The second use case would use C and D. So A and B are the clients for the data center who are subscribed to the service offered by the data center, for example, the internet service or other services that is provided by the data center. That is the first use case. The second use case is software-defined cross-connect for service providers. That could be an ISP, cloud, or internet infrastructure as a service, and etc. The service provider can provide each tenant any-to-any connectivity, which means it will be any VLAN connectivity across their tenants. For this use case, we would use C and D as the tenants. The C will bring in their own ISP to the data center, so they get connected to provision C with the required services, and D, same case. The major part that we need to understand here are multitenancy. So we have the layer of abstraction called the network virtualization layer. So we create the virtual networks which will span across multiple switches, whether 2 switches or 200 switches, it doesn't matter. The B is called the VTN, virtual tenant network, to provide multitenancy. The second part is the aggregation of bandwidth. So we have a 100 gig network, so the tenants are welcome to bring in a 100 gig service provider, or they can also do a 10 gig service provider. It's up to them. So that's the flexibility we offer here, and it's a central point of control and manageability. You will see that in how easy it is to control and manage entire network, a large network or a small network with several hundred switches. This is the web-based graphical user interface for the programmable flow unified network coordinator. This shows the physical topology with 4 switches which are connected in a leaf spine architecture. This has 100 gig switches. So now if I go into a switch, double click on the switch, I can open the switch port information, and it will say if it has topology from any specific port. For example, if it connects to another open flow switch, it will display information of that switch and which port it is connecting to. So all these are visible from this graphical user interface. This graphical user interface is not only for visualizing the physical topology, you can also create and manage the virtual networks. So you go to the configuration mode on this tool, and then click on the VTN tab over here, and you can see all the virtual networks that you have in the network. So there are 3 virtual networks already created in the network for this demo purpose, and I will be adding a new network or a new VTN called tenant D, where you can see the traffic information before and after creating the virtual network. The tenant 1 and tenant 2 are part of the use case 1 where they are sharing the network service offered by the data center, and tenant C and D, which is to be created, they would be bringing their own internet service provider. This is tenant 1 and this is going to be tenant 2, traffic for tenant 1 and tenant 2. So I have already created the VTN and I'm trying to ping the Google DNS server. You can see 8888 is reachable. It's good. And for the second client, I'm again trying to ping 8888 and it is again reachable. So these two VTNs are created. Now let me show what happens if the VTN is removed from the network. Go ahead and remove the tenant 2. I'm going to apply delete. It is now gone. So what should happen is this removing the VTN from the network should stop the traffic for the corresponding tenant. So we remove the client 2 VTN. So you can see the ping has stopped the moment we remove the VTN, and you will start seeing the network unreachable message in few seconds. Okay, so it says destination host unreachable, but you can see the traffic continues to go to 8888, so which is good. So this means you can create multiple tenants and manage each tenant, whether you have to enable the service or disable the service based on your policies. This is for a shared network service offered by the data center. Now let's look at, let us look at the use case 2, where if the client comes with an ISP to the data center, how you can manage or add a new tenant to the data center. Okay. So you can see the tenant C traffic is reaching the gateway. So in this case, you cannot, I'm trying to ping the gateway from the client end. So the client will bring the ISP and the ISP provides the gateway to the client and the client is trying to ping the gateway. In this simulation, it works. Now let us see the status of the tenant D. Tenant D is, in this case, tenant D is a new client who is added to the data center. Just by connecting to the ISP doesn't mean he has access because he has to go through the data center network. So now in this case, you are going to provision the new client in your environment. So what you would do is you go into this VTN tab, add a new VTN. Okay, let's name it tenant D. And we go into the tenant D. And here we drag and drop the virtual component called vBridge, which is responsible to handle the layer 2 traffic within an environment. In this case, we are not going to select any VLANs. We are not going to select any IP address range or anything. We are creating the vBridge instance, which is capable of handling the layer 2, and it will just transport the traffic from the client to the gateway. So this is what we are doing in this network, and this we can also call it as intelligent patch panel. So where we can group a number of ports and forward the traffic from the client end, maybe 4 ports from the client end to a single port at the gateway. So now let me get into the virtual bridge and configure. So let's see again, the traffic is still down. So I'm choosing any VLAN ID, so which means it can support 4,000 VLANs. So the clients can choose any VLAN they want on multiple sites or to their ISP, and we would just be forwarding those VLANs or the traffic across the network. So once we apply this, you can see the traffic has started to be successful, which means the client is now able to reach the gateway. With that, we can see how the network can be centrally managed by the network coordinator by just drag and drop of the virtual bridge instance, which is the layer 2 construct, a virtual construct, and we don't have to assign any VLAN if it is site-to-site or multi-site connectivity, and we can just create a VLAN to the vBridge if it requires the shared connectivity, like the data center service being shared for multiple tenants. So let's bring in the case. Let's bring that tenant 2 back online. So we saw the tenant 2 is still unreachable because the VTN was removed earlier. So let me add the tenant 2, and the configuration is the same as before with a minor change. I'm going to keep the name as is. I go into this vBridge, port map. So this can be any name, but I'm choosing something I can. Here, the group, VLAN. So the data center operator chooses to provide this VLAN, this client with VLAN ID 200. So that is the same number I'm using here. So once this is applied, you can see immediately the traffic is reachable to 8888. The client has internet access. So with that, I would conclude this demonstration and a quick tutorial on the SDN solution offered by NEC and Pica8. For further details, please contact us directly. Thank you.